Hello and welcome to Relyence Training on getting started with Relyence Reliability Prediction. In this tutorial, we'll focus on adding data in Relyence Reliability Prediction. We'll cover adding an additional subsystem to the analysis tree and adding a new part to that new subsystem. We will assume that you have viewed our previous overview tutorial on getting started with Relyence Reliability Prediction prior to viewing this video. To start, we are signed into Relyence and viewing the parts table in our drone example analysis. First, let's add an additional subsystem to our quadcopter drone to represent a camera. In the toolbar for the analysis tree, we click Edit. This will bring us to the Edit mode for the analysis tree. Here we can insert as many child and sibling subsystems as needed to build our analysis tree and reflect the structure of the product or system. Before we insert, we make sure that the quadcopter drone is selected. Then we click the drop-down arrow next to Insert. We can add a new subsystem as a sibling, or at the same level as the quadcopter drone, or as a child, or as one level of indenture below. In this case, we click Child Subsystem to add the new subsystem at the same level as the motherboard and ground controller. The Insert Subsystem dialog appears. Let's enter Camera for the name, and then we click Insert. Now we can see the camera subsystem has been added as a child of the quadcopter drone. Note that we can also edit any of the subsystem properties in the rightmost pane. For now, however, we'll leave all the defaults. Once we're finished inserting new subsystems, we can click Save and Close. Note that the small red marks that appear in the corners of the various fields are simply indicating that the data has yet to be saved. Since we're done entering the new camera subsystem, we'll go ahead and click Save and Close. And that saved our changes and returned us here to the parts table. Since the camera subsystem is still selected, we note that the parts table is empty since we have not yet inserted any parts. To insert a new part, we will take advantage of the built-in parts library included with Relyence Reliability Prediction. Relyence is pre-packaged with a database of commonly used components to aid in data entry. Note we can turn this Relyence library on or off and also supplement this library with our own parts and part data. You can find more details about parts libraries in Relyence Reliability Prediction in the Relyence Help. To insert a new part from the parts library, we click in the part number cell, and we can start typing the part number for the part we want to add. I'll begin by typing 74, the first two characters of the part number. We see Relyence now provides us with a drop-down list of existing parts in the parts library with a part number starting with 74. As we type more characters, the list will continue to filter. Let's select part number 74LS00 from the list, and then press Tab to complete the part entry. Note that Relyence automatically populated some data for this part. This information is stored in the parts library. Details like category, subcategory, and description, for example. It's important to note the category, subcategory, and type fields. The category, subcategory, and type fields are used together to define the particular type of component we are using. As in this case, the type field is not always required. It will be automatically enabled or disabled as needed. For each part, category, subcategory, and type, if required, must be entered in order to calculate a failure rate. If one or more of these required fields is not entered, Relyence will display a 0 failure rate when calculating. In this tutorial, we are populating data from the parts library, but we can also insert our own parts by selecting a category, subcategory, type if applicable, and any other fields we know about the part. There is also a Search Parts feature, and this can help us find parts from the Relyence Parts Library, our own parts library, as well as the NPRD, EPRD parts libraries. Feel free to consult the Relyence help for more details on the Search Parts feature. Now, the parts table contains many different data fields that are shared across various part types, but it does not include the data fields specific to individual category, subcategory type combinations outlined in the prediction calculation models required for calculations. To view these additional fields, we click To Form in the far right of the toolbar, and we see that a lot of the part data has been entered for us. This was based on data found in the parts library. We can complete the data entry by entering the package type, and temperature rise, for example. Note that if we do not know the value for a particular field, we can leave that field blank. Relyence will automatically use average default values for any blank fields while performing calculations. And then as more data becomes available, we can always add it. Ultimately, the more data parameters we enter, the more accurate our predictions will be. We see the red marks for the various data fields once again. So when we're ready to save the details for this part, we'll simply click Save in the toolbar. Before we continue our review of this sample part, please also note that parts lists can be imported to Relyence Reliability Prediction as well as an efficient way to enter large numbers of parts in an analysis. Next, let's take a look at the pi factors for this part by clicking the Factors button in the toolbar. The pi factors dialog appears. It shows the factors that contribute to the failure rate of the particular part. For this part, we can see that the pi-q value is high, which indicates that the quality level for this part is a large driver of its failure rate. In order to reduce the failure rate of the part, subsystem, and overall system, perhaps we could consider a higher quality part with a lower pi-q value. Whenever we've finished reviewing the pi factors, we can simply click Close to return to the parts form. It's important to note as well that we do not have to save our data modifications in order to see new pi factors. The pi factors dialog will show us the pi factors associated with the data as it appears on our display. This allows us to make edits to our data parameters while here on the parts form, see the resulting effects in the pi factors, before we determine if it's appropriate to save and alter our analysis. To return to the parts table, we click the To Table button in the far right of the toolbar. At this point, we can click Calculate in the sidebar to compute an updated quadcopter drone failure rate, or click Report to see an updated report as shown in the Getting Started with Relyence Reliability Prediction Overview tutorial. This concludes this Getting Started with Relyence Reliability Prediction tutorial, with our focus on adding reliability prediction data such as subsystems and parts. Thanks for watching. Please visit our website or contact us with any questions or to obtain pricing and purchasing information.